Hey guys, here's this homework video. I'm probably going to go through it pretty quickly because I'm tired because I just got back from parent-teacher conferences and I am done working for today. So let's try and get this done quickly. Alright, so for the first question, the graphs of the linear function f and the linear function g are shown in the figure above. If h of x equals f of x times by g of x, then h prime of 4 is equal to, so in this problem we are going to find, we first need to find h prime of x, and then we can plug in 4 into that derivative. Okay, so now notice here that this is a product of two functions of x, and so let's first find h prime of x. So the product rule is the first, so really depends, it really doesn't, the thing about the product rule is that that multiplication is commutative and so is addition. So the order, it can be written in different ways, and so it just really doesn't matter too much. But in any case, how I say it, so I do the first function, which is f of x, times by the derivative of the second, plus the derivative of the first, times by the second. So that would be the derivative of h of x. And then h prime of 4, I'm going to plug that in. That's going to be f of 4 times by g prime of 4 plus f prime of 4 times by g of 4. And I'm going to get all this information from the graphs that are up here. So here's the function of f. So let's get what we need from here. So what would f of 4 be? So at x equals 4, f of x is equal to 2. So that's equal to 2. And then g of 4, so at x equals 4, g of x is equal to 1. Okay, now f prime of 4, since it's a linear function, the slope is always constant. And so the slope here, just up 1 over 1, up 1 over 1. So you can see that the slope here is 1. So that means at f prime of 4, it's going to be 1. G prime of 4, again, g is also linear, so that means the slope is always constant. So I can see here that we have a slope of 2. Wait, no we don't. We have a slope of... I'm getting mixed up with my lines, aren't I? I'm going to go up 3 and over 2, because that's... There we go. So the slope is 3/2. Okay, and now that I have these 4 values, I'm going to plug them in. So f of 4 we said was 2. G prime of 4 was 3/2. Plus f prime of 4 we said was 1. And g of 4 we also said was 1. So this is going to be equal to, when I multiply those together, that's just going to be 3 plus 1. So that's going to be 4. There we go. Alright, so for 2, we have f of 2 is equal to 2. So this is giving me something that I might need. Same with this right here. And it gives us the function g of x. And what is the value of g prime of 2? So again, we're going to find the derivative of g first, and then we're going to plug in 2. So let's find g prime of x first. So the derivative of g, I'm going to need the product rule again, except now it's explicitly giving me one of the functions as x to the third, and then implicitly giving us f of x, meaning that we don't know what f of x is, but that's okay, we don't need it because we have values of f and f of x here. So g prime of x is going to be the first times by the derivative of the second, plus the derivative of the first, the derivative of x to the third is 3x squared, times by the second. And then we're looking for g prime of 2, so let's plug 2 in. 2 to the power of 3 is 8. F prime of 2 is going to be equal to 5, plus 3. Now, if I plug in 2 right here, that's going to give me 4. 4 times by 3 is going to give me 12. And then f of 2 is going to be equal to 2. So that's 40 plus 24. So that's going to be equal to 64. Okay. I think that's it. Let's try 3. We're given the function f of x equals e to the x times by sine of x, and we're just looking to find f prime of x. So we're going to need the product rule. So f prime of x is going to be equal to the first, which is e to the x, times by the derivative of the second, and the derivative of sine is cosine of x, plus so e to the, plus the derivative of the first, and the derivative of e to the x is e to the x, times by the second. Okay, and then it looks like if you look at the answers, notice that it's not there. It looks like that they are factoring out the e to the x because both terms have it. And then if I do that, I'll be left with cosine of x plus sine of x, and then that would be this one right here. Okay. For 4, we have a table with the values of f prime, g, and g prime. The table above gives those values at x equals 0. If h of x is given here, find h prime of 0. So we're looking to use the quotient rule. So let's use h prime of x. And the quotient rule, if you guys remember that silly kind of a rhyme that I gave in class. So h prime of x, the quotient rule, is low, which is g of x minus 1, d high, so the derivative of the top would be 6f prime of x. So here I have low d high, meaning the bottom times the derivative of the top. So low d high minus high, which is 6f of x, d low, so the derivative of the bottom, which would be g prime of x, and the derivative of 1 is 0, so plus 0, so I'm just going to write g of x. So again, we have low d high minus high d low, square the bottom, and away we go. So there is our derivative of h of x, and we want h prime of 0. I'm going to do that down here. So h prime of 0 is going to be equal to, so here we have g of x. G of 0 is negative 2. So that becomes negative 2 minus 1. So that's going to be negative 3 times by 6. And f prime of 0 is 1/2. So times by 1/2 minus, and then we have 6. We want f of 0. So f of 0 is going to be 4, so that's going to be 6 times by 4. And then we have times by g prime of x, and g prime of 0 is going to be 3/2 all over. And then we're going to plug in 0 here. G of 0 is negative 2. So that becomes negative 2 minus 1 squared. Okay, let's just go through, do some arithmetic here. That's going to be 3. That's going to be negative 3. You multiply them together, you get negative 9. And then minus, you're going to have, all these are being multiplied together. That's 6 times 4, and that's going to be multiplied by 3/2. So 4 can be divided by 2, and that's going to give me 2. 2 times 6 is 12. 12 times 3 is 36. So minus 36 over 9. and that's going to be equal to negative 45 over 9, which is going to be equal to negative 5. And there you go. Okay, for 5, let f be the differentiable function. We have, okay, g is this function, find g prime of 8, so let's do g prime of x first. So we're going to use the quotient rule, so that's going to be low. I'm going to write this with exponents instead of roots, so low d high, so that's f prime of x, minus high, which is f of x, d low. Okay, so if I have x to the 1/3, the derivative of that is going to be 1, I'm going to write this a little bit further up. So d dx of x to the 1/3, that's going to be 1 over 3 x to the negative 2/3, and that could be written as 1 over 3 x to the 2/3. So now I need to remind myself where it was. So I did low d high minus high d low, and that's the derivative of that. So multiplied by 1 over 3 x to the 2/3 over, so we have low d high minus high d low, square the bottom, and so that's going to be x to the 1/3 squared. Alright, so we don't have a whole lot of room here, but now we're going to plug in 8. So we're going to plug in 8, and so g prime of 8 is going to be equal to, if I plug in 8 right here, 8 to the 1/3 is the cube root of 8, that's going to be 2, times by f prime of 8, which is 5, minus, I need f of 2, or f of 8, sorry, and that's going to be equal to 2, right? Yeah, it's going to be equal to 2. Alright, and then f, so that's that right there. Now, I'm just going to write this as being divided by, because this is just like in the numerator, this is in that denominator. So, but if I plug in 2 here, so if I plug in 2 here, the denominator is 3, meaning that's a cube root. So the cube root of 8 is 2, but then I'm raising it to the second power as well. So that's going to be 4 times by 3, which is going to be 12. And then that's all being divided by, if I plug in 8 here, the cube root of 8 is 2, squared, that's going to be 4. Okay, so this is going to be 10. I feel like I did something wrong. Something's not quite sitting right. No, I think we're good. Okay. I'm going to do minus 1/6 over 4. I want a common denominator here, so I'm going to multiply top and bottom here by 6, so that's 60 over 6 minus 1 over 6 over 4. That's equal to 59 over 6 times by 1/4 if I do the keep change flip, so that's 59 over 24. So that's going to be A. Okay, like I told you guys so many times already, the worst part about calculus is the actual algebra. I mean, this part right here, where we did the shortcut, that was the calculus. All of this right here is the algebra, and that was the part you all didn't like, right? Told you guys. So, alright. Alright, let's do this one. So f prime of x is going to be equal to, use the quotient rule. We're going to have low d high, and the derivative of cosine is negative sine of x, minus high d low, the derivative of natural log of x is 1 over x, so I'm just going to say over x. And then square the bottom, so natural log of x squared. Okay. Now, I'm kind of comparing my answers over here. It looks like they want to get this to have a common denominator so you can add those terms. And so I'm going to multiply this by x, therefore I can combine the numerator there. So if I multiply this by x, I get x, I'll put negative x. I'm also just, it looks like they're writing sine of x first, times by the natural log of x, minus cosine of x. This is all being divided by x now, and I'm going to do a keep change flip. So remember, I put this in one fraction, so I'm going to keep that like this. I'm going to change that to multiplication, and then flip the second, so that's going to be natural log of x squared. And then, so the numerator should look like that, and the denominator should have x natural log of x squared, which, so it's not c. Now we have x sine of x, negative x sine of x, minus cosine, so that's going to be b. Yeah, it's going to be b. Okay. All right, here, so if f of x equals secant of x, then this expression is, so I hope you guys are getting used to these. These are kind of weird, I know, but it's just trying to convey that this is a derivative. This is d dx, the derivative of f of x at pi thirds, and f of x is sine of x. So this is the derivative of secant of x at pi thirds. So the derivative of secant of x is equal, so that's just one of your derivative rules. Secant of x times by tangent of x. And then at pi thirds, so that's going to be secant of pi thirds times by tangent of pi thirds. And lucky you guys, you don't have to evaluate those. It's just asking for that. But if you did have to evaluate them, you guys would know what to do, right? Of course. All right, for 8, d dx of cosine of x times by tangent of x. Oh, I know you guys are going to hate this one, because you're going to use some trig identities, so this is going to be fun. All right, so let's make this easy. So this is the same thing as, so cosine of x times by tangent. Cosine is, maybe I can keep, it's cosine of x times by tangent of x is sine of x over cosine of x. So that's equal to, oh my gosh, derivative of sine of x. Whenever I made the key, I totally forgot that you could do this. And so if you guys look at my key, it's probably a lot more work because I actually chose to use the product rule here, and then I simplified using a bunch of trig identities. Well, that's embarrassing, but okay, derivative of sine of x is cosine of x. That was way easier. Okay, there you go. Which of the following correctly shows the derivative of cotangent of x? Okay, so let's go ahead down here. Let's follow these steps. d dx of cotangent of x. Cotangent of x is 1 over tangent of x. So, yep, we're all good here. Wrong. These two are wrong. So notice here that they decided to just take that, they said that this is just going to be taking the derivative of tangent of x. Nope, that's so not true. You can't just do that because it's a quotient. That is not true. So it's not going to be A or it's not going to be B. So it's got to be C or D. So it looks like from here to here, they're using the quotient rule. So low d high minus high d low square the bottom. Okay, that sounds good to me. So derivative of 1 is going to be 0. Derivative of 1 is going to be 0. Derivative of tangent of x is going to be secant squared of x. So I think that's where this one's going to be wrong, is because this should be, yeah, they did a plus sign right here. It's a minus, so that's where they messed up. So it's got to be C. So it's going to be C because they used a plus sign here, but it's low d high minus high d low. Okay. All right, this one's probably going to take a little bit of time. You're going to want your calculator for this one. Right? Yes, graphing calculator is required for this question. You're going to be using the derivative function in it. So the table above gives differentiable values of f and its derivative f prime at select values of x. So we got f and f prime of x for select values of x. Let h be the function defined given here. Do not try and take the derivative here by hand. Do not try and do h prime of x is equal to, and then you're going to be like, oh, well, it's a product, right? And I can just do the product rule. Yes, you could, except for the fact that we need the chain rule for this expression right here. We would actually need a double chain rule here. And we have not learned the chain rule. And so you guys don't know how to take the derivative of this by hand. So don't try and do it. This is what your calculator's for. Okay? But so for A, using values from the table, estimate f prime of 4. Perfect. So I'm going to use these values here. So f prime of 4 is going to be approximated by doing 4 minus negative 1 over 5 minus 3. That's equal to 5 over 2. And that's going to be our approximation right there. So pretty easy. Okay, for B, let m be the function defined by f of x plus h of x. Find m prime of 3. So, 1 second. I'm going to move this down here so I don't have to keep looking up. So, let's take the derivative. M prime of x is going to be equal to f prime of x plus h prime of x. So, we're just using the sum and difference rule. We can do this with the sum and difference rule. And then we want m prime of 3. That's going to be equal to f prime of 3 plus h prime of 3. Now, h prime of 3, well, I guess we'll start with f prime of 3 because that's in the table. F prime of 3 is going to be equal to 8. So f prime of 3 is 8, and h prime of 3, that's what we're going to use our calculator for. So let's go to the calculator, and then h prime of 3. So I'm just going to go to math, option 8, and we're going to do the derivative of, we're going to type in our function, so that's going to be x squared, and then we're going to do e raised to the cosine of 3x. So that's our function, and we're taking the derivative at 3, click enter, and h prime of 3 is going to be equal to negative 2.061. So h prime of 3 is negative 2.061, and I'm going to add that with 8, so add 8, and we get that this whole thing is 5.939. So this is going to be m prime of 3 is going to be equal to negative 5.939. Okay. C. Alright, so for 3 we have the function n. So let's do n prime of x. N prime of x is the product of the two. So we're going to use the product rule. So the first times by the first times by the derivative of the second plus the derivative of the first times by the second, and we want n prime of 5. So f of 5, I'm not going to write them here, f of 5 is equal to 4. So this is going to be 4 times by h prime of 5. H prime of 5. Let's find out h prime of 5. So we're going to copy down this function right here, and we're going to replace this with 5. And we're going to click enter. So h prime of 5 is negative 18.138. So negative 18.138. That's what's going to go there. I really don't want to write that there. And then f of 5 is equal. How do I do this? Sorry, I'm trying to think a good way to write this without being too lazy. So we said f of 5 is 4. I'll just do 4 times by h prime of x plus f prime of 5. So f prime of 5 is going to be 3. And then that's going to be multiplied by h of 5. And then we need h of 5. So in this case right here, let's go here. I'm going to do a kind of a trick here. So I'm going to store 5 into my function, or into my variable. So I'm going to say 5, and then on the left side where you see that arrow, bottom left, you see that arrow pointing to the right. So I click on that, and then I'm going to click I'm going to click the variable button. I'm going to click enter. And now, anytime I use x in this window, it's going to think that x is 5. So now that I have that, I can just type in the function x squared e raised to the cosine of 3x. I can just click enter. So h of 5 is going to be 11.695. So h of 5 is going to be equal to 11.695. Okay, so now I'm just going to put this all into my calculator. So it's got to be 4 times by this right here plus 3 times by that right there. So I'm going to try and do that all here. So we're going to do 4 times by, it was h prime, and I have that right here. And then we're going to do plus 3 times by this right here. Click enter. I got negative 37.466. So this is going to be equal to negative 37.466. Okay. And then for the last part, okay, for the function p, so p prime of x, we're going to use the quotient rule. So low d high minus high d low, square the bottom. Away we go. Okay, so let's get the values. We're using 7, so p prime of 7 is going to be equal to f of 7. And f of 7 is 6. So 6 times by h prime of 7 minus h of 7 times by f prime of 7, which is negative 2, all over f of 7 squared and f of 7. So that's going to be all over 36. So I need to find h of 7 though, and I need to find h prime of 7. So let's go here. Let's first find the derivative. I'm just going to go up here. I'm going to put in 7 right there. I get negative 63.024. So negative 63.024. And then h of 7. So I'm going to go here. I'm going to do 7 store as x. I'm going to click enter. And then I'm going to go back up here. copy down this expression and click enter, and then I get 28.335. So 28.335, and then yeah, I can just plug away. So we're going to, this might take a couple more steps, but let's do 6 and then times by h prime of 7. So that was this line right here, minus, and then we're going to do h of 7, which was that right there, and that's going to be multiplied by -2. That's my numerator, and then I'll just have to divide that by 36, and I get -8.92, so -8.93. -8.930. There you go. So that one's a bit tough, but not too bad. Kind of fun. Okay, and that should be everything for this homework assignment.